Hi guys, and welcome to another video. This video in particular is focusing on the sine and cosine rule. So this series is all about using these formulas on non-right angle triangles to find different sides and finding angles of them. So the first one I'm going to show you is the sine rule. The next one will be the cosine rule, and then I'm going to go through a few different examples as well. So first of all, this is just a sine rule introduction. So what is the sine rule? So on your screen at the moment, you can see I've got a non-right angle triangle, and I've labeled some of the sides and some of the angles as well. I'm using the letters A, B, and C. Of course, you can use any other variables. You can say that is X, Y, Z, or whatever you'd like. It's just more commonly used as A, B, and C. I've also got the formula up there, so it's A over sine A equals B over sine B. And the importance of the different capitals and lowercase is to differentiate between sides and angles. So you might see sometimes that the letters capitalize a difference, and sometimes it's like sine capital A rather than sine lowercase a. It doesn't really matter too much as long as you know when you're using the formula, when to use the angle and when to use the side. All right, so for this one here in particular, you can see I've got A here, A, and this capital A here, and you can see that they're just like corresponding. The main reason why I say that is because they're opposite each other, so they're directly opposite each other, and because of that, you know that they're a pair and they'll go together. So that's why when we write it in this format, you're always going to have a side on the top and then the angle with sine on the bottom. Okay, so it's not often that it's not ever that you get just the angle on the side, so you can't just write 60 degrees over like sine over something in centimeters. Like, it doesn't really make any sense. So making sure you know when to use which variables. All right, so then you've got B and C, so then you've got B and B, that's another pair there, and then you've also lastly got this one here where they're also pairs. And it's really important to actually be able to identify them, because sometimes in triangles, sometimes they might look slightly different, and it might actually be quite hard to identify them because of the angles and stuff like that. I've done that a few times myself, where I accidentally use the wrong numbers and everything in the wrong pairs. So just being able to label them is just really a good thing to do, especially when you're first starting off doing the sine and cosine rule. All right, so you can see here that I've actually written specifically that this is how to find a side. Of course, you know that just like in regular trigonometry, sine, cos, and tan, when you're trying to find an unknown angle or an unknown side, you've got to rearrange the formula. So sometimes you've got to rearrange it to find a side. Sometimes you've got to rearrange it to find theta or an unknown angle. You can do the exact same thing with this formula here to actually find an unknown angle. And the way you do that is if you flip one of these fractions or find the reciprocal, using that fancy terminology there, you can actually find the angle. Okay, so from here you can see that I've actually basically just flipped both sides around. You can't just flip one side, you've got to flip both sides. And if I want to find an angle, for example sine A, I would have to do sine A is equal to sine B over B times A. Okay, and then from there I've got to find the inverse to get A on its own, that angle on its own. So I'm going to do A is equal to sine, so that -1 just indicates as the inverse of, I'm just going to write the A on the top with it, like that. And that's how you can find an angle of unknown triangle when you're given two of the sides and one angle, okay? As long as they're corresponding pairs. All right, so this is just a quick video. I just wanted to show you the formulas a little bit more and kind of go a bit more in depth. Check out the next video for the cosine rule. Thanks, guys.